1, we are going to talk about a new type of equation, a new form of a linear equation, and that form of the linear equation is called slope-intercept form. Okay, slope-intercept form. So now we know what slope is. We know what the intercepts are. Now we're going to put it all together. Slope-intercept form is y equals mx plus b, and you just need to make that your friend. You just need to know y equals mx plus b. In this equation, m is the slope, b is the y-intercept. Okay? So here, it's asking us, what is the slope-intercept form of the equation of this line? Well, for slope-intercept, you need two things. You need slope and y-intercept. What's the y-intercept here? What point? Y equals what? 3. So the y-intercept is b. We say b equals 3. Now, for the slope, remember we have to do rise over the run. So to go from one point, the left point, to the right point, I have to go up a little bit, so that's plus 2, right? And then I have to go horizontally 1, 2, 3, so that's plus 3. So the slope will be 2 over 3. So far, we could do that last chapter. Now, to write the slope-intercept form, it's y equals 2 over 3, that's the slope, x plus 3. Okay? Huh? Y-intercept. B is the y-intercept. It's right over here. B is the y-intercept. Okay, so now, write an equation in slope-intercept form for a line with slope of -1/2, y-intercept of 3. Slope of -1/2 means m is -1/2. Y-intercept, b, is 3. So now, y equals m, the slope, -1/2 x plus 3. So always say it to yourself. Y equals mx plus b. Mx plus b. M and b. Just plug them in. Okay. Here, write an equation, right? So again, my equation is going to be y equals mx plus b. So I need m and I need b. Okay, b first. It's this one. So b is how much? 1. For the slope, right? So first of all, let's graph this line. When you graph this line, this is how it looks. Oops. For now in the notes, you don't have to. Okay, so now let's find the slope of this. From the left point to the right point, I go down 2, so -2, over how much? 4. Okay, so slope is, slope is -2 over 4, -1/2. Now I put it all in. Y equals, what's m? -1 over 2. X plus b is 1. So this is y equals -1 over 2x plus 1. Okay, question. Morgan, did you have a question? Remember from the last chapter, always start with the left point and go to the right point, just like we did in the last chapter. Okay, so this one, let's graph the line. So I go, okay, so first y-intercept. How much is y-intercept? -4. So here b is -4. And then for the slope, I'm going to go from the left to the right point. So first I'm going to go up. I'm going to go up a lot. How much do I go up? plus 10. And then how much do I go across? Plus 3. So m is 10 over 3. So now, the equation is y equals mx plus b. So y equals the m, 10 over 3, x plus the b is, the b is negative 4. So this is going to be minus 4. Now look, at the end of the day, when you're done writing this, in your equation, you have to have the y and you have to have the x present. Don't forget to put the x and the y in there, otherwise it's not an equation. Yes. B is the y-intercept. B is where the graph crosses the y-axis. It's right here. Look, B is the y-intercept right here. Okay? Okay, so this one, slope-intercept. So what's B here? 7. And what's the slope? Are you sure? Negative 1 over 4. Okay, so rise over the run. So m is negative 1 over 4. So y is what first? What comes first? Then what? Then? Good. Okay? Okay, what's b here? B is negative 5. Okay, what's slope? What do you think? Plus 8 plus 3. Yeah, so 8 over 3. Okay, so y equals what first? 8 over 3 times x and then minus 5. Good. Because it'll be plus negative 5, right? So it should have been 8 over 3x plus negative 5. But plus and minus together, that's minus. Right? So this will be minus. No, we do minus. Because you have to simplify. Okay, so now, how do we graph? Now we're going to go backwards, right? Now I'm going to give you this, and you're going to write this, and you're going to draw the graph. To do this, same as before, first we do the B. So first, plot B. That's the y-intercept. Okay? Then, using M, you have to count the rise, and then you have to count the run. So remember, if it's positive, it goes up. If it's negative, it goes down. And then right and left. So let's just do this. Okay, then you have to draw the points. Okay, so now look. When you're doing, okay, so let's do this one. What's the y-intercept? What number here? 5. So first I put in the y-intercept, B, 5. I just put a point there. Now I need to do the slope. When you're doing the slope, first use the sign to go up or down. So the way you're going to do it is, from here, if it's positive, you're going to go up. If it's negative, you're going to go down. So now, this is 1 over 4. That means I go up 1, right 4. Okay? So, from here, I go up 1, and then right 4. 1, 2, 3, 4. And I put the new point there. So you should only have 2 points. Go up 1, right 4. 1, 2, 3, 4, and put the point there. Okay? You should have 2 points, and then you connect. On the homework, you have to connect with a ruler. Okay? Yeah. No. Yeah. Okay, that's not relevant to here. Well, let's talk about this. Okay. Here, this is the B. So I put a point at 3 and stop. Now, my slope is 2, but that's like 2 over 1. That means up to right 1. So here, look, up to right 1, and that gets me there. So draw the line like that. Okay? Okay. Now, what if the equation is not in slope-intercept form? Well, then you have to put it in slope-intercept form. You have to solve for y first. So that's why we were learning all the other stuff from before. So here, to solve for y, what am I going to do? Minus x. Yeah, minus x minus x. So I get negative y equals negative x minus 3. Now what do I do? Divide by negative 1, right? So I get y equals positive x, positive 3. I need to solve just for y, positive y. So now I have y equals x plus 3. Okay, now 3 is the b. 3. Okay, what's m? What's in front of the m? 1. If there is no number, the coefficient is 1 because this is 1x, right? So in here, it's 1 over 1. That means from my point, where do I go? Up 1 over 1. Good. Up 1 over 1 here. Okay, good. Okay. Jack, I saw you sounding that out. I heard you sounding that out. Up 1 over 1. Yep. Yeah, if you wanted to put more points, that's what you would do. Okay? We don't need that. Thank you. Okay, so this one, what am I going to do to solve for y? Divide it by 2. So now this becomes y equals x over 2. That's like 1 over 2. This is 1 over 2x plus 3. So I put the 3 here. Up 1 over 2, right? For the slope, up 1 over 2. That's what that looks like. Okay? Yeah. Okay. Now, look at this one. It's y equals 5. There is no something x. Well, guess what? When you have something like this is like y equals 0x plus 5, right? What kind of line did we get when you got 0 slope? What? Horizontal line. Look at you. That's a horizontal line, right? So whenever we have y equals a number, that is a horizontal line. But hang on, what's the y-intercept though? 5. So the y-intercept is still at 5. That hasn't changed, but it's just a horizontal line through that point. Okay? So y-intercept is 5, right? This is the b. It's just the slope is 0, so you get horizontal line. Okay, here, I need to solve for y. So let's add 12. So I get 2x plus 12 is equal to 4y. Now what am I going to do? divide by 4. Exactly. So let's go here. Y equals half x plus 3. 3. So it's 2x plus 12, right? Huh? Plus 3. Because it's 2x plus 12, and then we divide it by 4, so it's plus 3. Well, so first we added 12 to both sides. I did plus 12 plus 12. So I got 2x plus 12 equals 4y, because this 12 went away. Then I divide by 4, so I get 1y equal to... Yeah, I added it from there. Okay. So now, y-intercept is 3. And what's the slope? Where do I go? Up 1 over 2. Good. Up 1 over 2. Okay? Okay. So let's talk about real world examples. If a quantity changes at a constant rate over time, right? So every day something grows by 2 inches. That's a constant change. Then it can be modeled by a linear equation. In that case, the y-intercept is the starting point. The slope is the rate of change, just like we did last week or last chapter. So look at this. The number of girls competing in high school sports has increased an average of 500,000 per year since 1997. 500,000 per year, that's the rate of change. So that's your slope. In 1997, when it all started, there were 2 million girls in high school. So this is the starting point, right? This is the starting point, or B. This is the rate of change, or M. Okay? So M is the rate of change, so it's a half. I can ignore the millions. B is so this is the rate of change. B is 2, that's the starting point. Okay. So now it says write a linear equation. Well, y equals mx plus b. So y equals half x plus 2. You see how it's the same thing, right? So now let's graph it. So look at this. This is the change. So this is the number in millions. So if I put 2 here, it's 2 million, right? Okay. So the starting point, the y-intercept is 2. And then I go up 1 over 2. So that looks, like a line. Now, if you want to orient yourself, you can go, if you want to put more points, from here you can go up 1 over 2 again, up 1 over 2. Each time it changes by the same step. So this will be like this. Okay? No arrow on the other side, right? You can't extend on the other side because it doesn't go past there. Estimate the number of girls competing in 2005. Well, where is 2005? How many years have passed? 8, right? So that means from 1997 to 2005, that's 8 years. So x is 8. So this is going to be y equals, remember it was half x plus 2? What's x now? 8. Right? So that's half of 8 is 4 plus 2, 6. Okay, so does that mean there are 6 girls competing in 2005? 6 million. Good. Okay? Yeah. Yes, you can, but you should also be able to do it like using algebra. Right, but if you look on the graph too, right? You see how like if you graph it correctly, look, we did get 6, right? How cool is that? Right? Yeah. Okay. But like had I messed up my line because I didn't use a ruler, it may have gone off, right? And then you would get the wrong answer. Okay. All right. Suppose you have already saved $50 towards the purchase of a new television. You plan to save 5 more each week in the next several weeks. Write an equation for the total amount T you will have in W weeks. Okay, I need a slope and a y-intercept. So my slope, right, is going to be the rate of change. And my y-intercept is going to be the initial. So what's the initial value here? 50. Right? That's your B. And what's the rate of change? 5. Okay? So the equation will be y equals mx plus b, y equals 5x plus 50. Okay, but this is telling me write an equation for the total amount T that you will have in W weeks. So that's going to be T equals 5W plus 50. Okay? That's awesome. Okay, now we're going to graph this. My y-intercept is 50. Yes? So I need to calibrate this, scale this, so I can go 50, right? Okay, so what if, okay, by 5 is too little. What if I go by tens, right? So let's go 10, 20, right? And so on, okay? And it goes all the way to 100. And then this will go by ones, because it's like $5 a week. Okay? And you see how this is W and this is T? So this is number of weeks, and this is amount saved, right? Okay. Where do I put my first point? 50. Now, I need to go how much up and how much over? 5 and 1. So 5 is in between. 5 and 1, that's here. Okay? And then, so that's, and then another 5 and 1 would be there. So this is how this is going to look. All right? So again, especially with this, when we went in between the bars, you want to go with the equation and not the graph. Total amount saved after 7 weeks. So what's the equation? The equation was T equals 5W plus 50. 5 times 7 plus 50. 35 plus 50. 85. So after 7 weeks, you will have $85. That man, that child is going to be saving for a long time, right? Right? Because if after 7 weeks you only have $85, you gotta up the savings, you gotta up the slope, right? Or you're just never gonna have a TV because the price is also, oh my god, this is like a non-winning game. The price is also increasing. Man, this person is never gonna have a TV. Okay? He might as well just give up, or she. All right. Okay.